So let's just see how we can search for a node in the binary search tree. So as we know, in a binary search tree we have the property where the left child will always be lesser than the root and the right child will always be greater than the root. So this binary search tree property will help us search one value faster. So like an example, suppose you are searching for a value in the binary search tree. So if the value is smaller than the root, in that case we're gonna search for the value in the left subtree. If the value is larger than the root, in that case we're gonna search for the value in the right subtree. So that means when our tree is well balanced, then the searching will be really efficient. It will have the time complexity of order of log n. So here in this case, because the tree is balanced, so it will have the searching complexity of order of log n. Otherwise, if the tree is skewed, so when our tree is skewed, that means every node has only one child, just looks like a linked list. So in that case, it will have the time complexity of order of n. So this is the best case and this is the worst case. So here we have the searching function. So the function takes the root node of the tree and the key that we are searching for. So first of all, we're gonna check if the root is null. So if the tree is empty or the root key is the key. So that means if we have found the key, in both of the cases we're gonna return root. Otherwise we have to check if the key is smaller than the root. In that case we're gonna search for the value in the left subtree. So we're gonna recursively call the function and we're gonna look for the value in the left subtree. So otherwise we're gonna recursively look for the value in the right subtree. So that means in the right subtree. So suppose you are looking for the key 3. So first of all you have to compare that with the root value. So because 3 is lesser than 5, so that means we are only going to search on the left subtree. And again 3 will be compared with the root 2. So because 3 is larger than 2, so that means you're going to look for the value in the right subtree. So because we have a match here, so that means we have found the value. So this way we can search for any value in our binary search tree. So here we have the code. So first of all, this is the structure for a node, and this function is to create or allocate memory for a new node, and this is the function to search for a key in our binary search tree. So inside the main method we have created our binary search tree with all of these nodes. Now here we can search for a key. So suppose we are looking for the key 7. So we have to call the search function, and here we have to pass the root of the tree and the key that we are searching for. Now this function will return the result. Now we're gonna check if the result is not null, then we're gonna print key found. Otherwise we're gonna print key not found. So because the key 7 is present in our tree, so we are getting the output key found. So this way we can perform the search operation in the binary search tree. So hope you understand the concept. See you in the next one. Take care.